Hi, in this video we'll be carrying on with histograms. So in the last video I showed you how to read a histogram by finding the area of the bars and that you could split bars up to find other values. So in this video I'm going to be showing you how to draw a histogram if you're given the information in a table. Okay, so the first thing you'll need to do is make a note of this. That when you draw a histogram in an exam or whatever, you will have everything you need to know apart from the height of the bar. Remember, the height of the bar is called the frequency density. If you've forgotten why that is, go back to the last video. It's not that important, to be honest though. Okay, so what you're going to be doing today is working out how tall a rectangle should be if you know its area and its width, and then drawing a bar to match on a set of axes. So your first job then, little starter task for you here. I want you for each of these 4 rectangles to find the height of the bar. So if you draw them, work out the height of each bar. There's no units, and when you're ready, press play on the video. So the first one then, it's got an area of 30 and we're missing the height. So 6 times something is 30, or if you spin it round, 30 divided by 6 is 5, so the height must be 5. For the next one, 8 times something is 24, or if you flip it around, it's 24 divided by 8, the height must be 3. Next one's a little bit trickier. We've got to do the area, which is 16, divided by the width, which is 10, so 1.6. And you can always check your answer by multiplying that back out. 1.6 times 10 is 16. And then the last one, which is probably the trickiest of the lot then, what we need to try and do is 36 divided by 20. How you do that without a calculator, I think you've got a couple of ways. You could do 36 divided by 2 is 18, so 36 divided by 20 must be 1.8. Okay. The other thing you could do is make the top and bottom 10 times smaller and do 3.6 divided by 2, which is 1.8. Okay. You may even need to do bus stop division for some of these if you don't have a calculator, which you probably won't for histograms in an exam. So the height of this one, you should get 1.8. And remember, you can check it. 1.8 times 20 is 36. Now basically, that skill you've just done there is what you're going to be repeating when you draw your histogram, except the information will be given to you in a table and you'll have to figure out from there. So let's have a look at a question then. Now this is basically what you've just been doing, but put into the language of histograms. So if I do it in normal language first, the height of a rectangle is its area divided by its width. Or in histogram language, the frequency density on a histogram is the frequency divided by the class width. Okay, no different to what you were just doing, it's just the language is different. Frequency density means height, frequency is the area, and class width is how wide the bar is. Okay, and now I've got a table here which shows the ages of people coming out of a leisure centre, and you can see if you read across it, we've got 0 to 10, 10 to 20, 20 to 25, which is smaller, 25 to 40, which is quite a lot bigger, and 40 to 60, which is really big. That's got a width of 20. Okay, so we've got a width of 10, width of 10, width of 5, width of 15, and a width of 20 on the end. So all of these bars are different widths, which we know happens when you've got histograms. And so to work out the frequency density, which is how we're going to draw a histogram, we need to use the formula up there. So frequency density is frequency divided by class width. So if I put the class widths on the top first of all, so this one is 10 wide, 10 wide. That one's only 5 wide because it goes from 20 to 25. This one is 15 wide because it goes from 25 to 40, and the last one is a width of 20 because it goes from 40 to 60. So the calculations we're going to be doing are 8 divided by 10, 19 divided by 10, remember this is the area along the bottom row here, 12 divided by 5, 15 divided by sorry, the other way around, 30 divided by 15. So 30 divided by 15 and 24 divided by 20. Now, to make it look like the last ones you did, for the first bar, basically it would look like this. It's got a width of 10 and it's got an area of 8. And I'm asking you how tall it needs to be. So 8 divided by 10 is 0.8. So 0.8 tall, and that's what we're going to draw on our graph in a minute. Our second one, these are not to scale, has got an area of 19 and a width of 10. So 19 divided by 10 is 1.9. Okay. The next one is thin. It's only got a width of 5, an area of 12. So 12 divided by 5. Now what you might have to do here is a bit of proper division to work this out. So 12 divided by 5. So 5 doesn't go into 1. 5 goes into 5 goes into 12 twice, remainder 2, and you'll need to put a 0.0 for your remainder 2, and then 5 goes into 24 times. So 12 divided by 5 is 2.4. Then we've got 30 divided by 15, so nothing complicated there, so that's 2. And 24 divided by 20, which is exactly the same as 2.4 divided by 2. I've just made both bits of the question 10 times smaller, so 1.2. So that must be 1.2. Okay, so what we've just worked out in blue is the height of each of the 5 bars, and height means frequency density, which is our y-axis. Okay, so what you'll need now is a set of axes. So along the bottom we need to go from 0 to 60, equally spaced, okay, as wide as you can get away with on your page. Maybe put a 10 every 4 or 5 squares maybe. And then we're going to go up to 3. Our biggest frequency density was 2.4, but I don't like to stop on the very last number, so we'll go up to 3. And my scale here is I'm going up in 0.2, so it goes 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.6, 2.8, 3. Alright, now if you've got more room you could spread it out more if you like and go up in 0.1s, as long as you get up to 3 and you've got a sensible scale. If you look at the sort of numbers we're going to have to find here, I wouldn't make it too small an axis because it's going to be tricky to find these values. Okay, so how do we draw our histogram then? So the first bar goes from 0 to 10, and we've calculated that its frequency density is 0.8. So with a pencil and a ruler, our first bar from 0 to 10 has a height of 0.8. Okay, and an area therefore of 8. The next bar goes from 10 to 20, and it has a frequency density of 1.9. So 10 to 20. Now 1.9 on my scale is halfway between 1.8 and 2. Okay, because I've gone up in sort of odd, even tenths if you like, and we've got an odd tenth. Now the next bar is different because it goes from 20 to 25 and a height of 2.4. So it's thinner. So it only goes to 25, so that's there. And it's got a height of 2.4, which is there. But be careful you don't just copy the width of the other bars because this one is a thin one. The next bar goes from 25 to 40 and has a frequency density of 2. So from 25 to 40 and a frequency density of 2. And our last bar goes from 40 to 60 and has a frequency density of 1.2, which is there. Okay, and if I zoom out a little bit so you can see all of that on one page. There's my finished histogram. So the steps were doing frequency divided by width to find the height, which proper name is frequency density, and then drawing the bars the correct widths and the correct heights based on the numbers in the table. And remember, on a histogram there will be at least one bar which is different to the rest, so don't go into autopilot mode when you're drawing. Concentrate. Okay, be careful on your division. If it comes out like massively different to the other numbers, you may have done something silly. So just be super careful on your division when you're calculating frequency density. And that's all there is to it.